Here we are with our next topic, partial derivative. Disclaimer, this video is for the integrated math students from the Nevis Sixth Form College. They have the handout and they will be following along. Says, when a function is expressed in terms of more than one variable, the partial derivative, and here we have the sign for partial derivative, is found. This is done by differentiating one variable while keeping the other constant. If z equals f of xy, the partial derivative with respect to x involves differentiating the x components while the y's act as constants. And this can be expressed as follows. The partial derivative with respect to y involves differentiating the y component while the x's act as constants and is also denoted as we see here. Now, other expressions of the partial derivative with respect to x are shown below, while the partial derivative with respect to y can also be expressed as shown here. Now, what does this actually mean? Now, usually when you're given a function, you have one variable, whether it be x, r, m, it doesn't matter, there's one variable. Now, if you see here in the function, there are two variables. We have x and y. So for us to differentiate a function like that, it says we find the partial derivative. Now here we have the partial derivative of f with respect to x, and above it says to find it, we are going to differentiate all the x components and the y's are going to act as constants. So if we go back to our function, to find partial derivative of f with respect to x, we're going to differentiate the x cubed as well as this 4x squared, while this y cubed and y to the 4 are going to act as constants. Now, differentiating the x cubed is quite simple. We know that we will get 3x squared as seen below. For this part, where we have 4x squared y cubed, we will differentiate this 4x squared to get 8x, but we will multiply by this y cubed because it's acting as a coefficient in this case. Meaning, if I had given you a simple function such as just the 4x squared to differentiate, this x squared can be differentiated to give us 2x, and we will multiply by this coefficient, which is the 4, to give us the 8x, which we know. So, in the same way, this 4x squared is a variable that we will differentiate to get 8x, and we are multiplying by this coefficient y cubed. In this side, remember, it's, the y's are acting as constant, so we know differentiating a constant gives us 0. So that's why if we're finding the partial derivative with respect to x, this y to the 4 becomes a 0, because once more, we're differentiating the x components and the y's are acting as constant. So with this, will give us an answer, 3x squared plus 8x y cubed plus 0. Now you don't have, minus 0. You don't have to put the minus 0 at the end. So that is our answer. For the partial derivative of f with respect to y, it's the opposite. We're going to be differentiating all the y's and the x's are going to act as coefficients / constants. So remember, now we're differentiating the y's. X's are acting as constant. So when I go to the function, this x cubed, which is acting as a constant, will give us 0. Because why? Because once more, differentiating a constant gives us a 0. When we go to this part of the function, we will differentiate the y cubed to get 3y squared, and this 4x squared is now acting as a coefficient which we multiply by, as seen below. And going over to this negative y to the 4 is simply minus 4y cubed. So that now gives us the partial derivative with respect to y to be 0 plus 3y squared times 4x squared minus 4y to the negative 4y cubed, as seen here. And all we do from here is simplify. So the 3 times the 4 give us 12, leaving us with 12x squared y squared, and we write back our negative 4y cubed. For the first question, we have, given that w equals x squared y minus 2x plus y cubed, find partial derivative of w with respect to x. So here we're going to differentiate the x's, and the y's are going to act as constants / coefficients. Differentiating x squared here gives us 2x. We multiply the y by the y coefficient. Differentiating this minus 2x gives us a negative 2. And this y cubed, which is acting as a constant, gives us 0. So leaving us with 2xy minus 2, as seen below. For the second part, the partial derivative of w with respect to y, going back to the function, differentiating this y, remember we're differentiating the y's now and calling the x's constants / coefficients. So when we differentiate this y, we get 1, and multiplying by this x squared coefficient, as seen here. There is no y here, so it's going to give us a 0 when we differentiate it. And this y cubed will simply be 3y squared. So the answer becomes x squared plus 3y squared. In our second question, we have the function f of xy equals 3x cubed y squared minus 2xy minus y raised to negative 4. Finding the partial derivative of f with respect to x, differentiating the x's. This 3x cubed will give us a 9x squared, and we multiply by the y squared coefficient. This negative 2x will give us a negative 2, and we multiply by the y coefficient. Here there is no x, so it's simply 0. So giving us an answer, 9x squared y squared minus 2y. In the second part, to find the partial derivative with respect to y, differentiating the y's now, this y squared is 2y, and we multiply by this 3x cubed coefficient. Here we differentiate the y to get 1, and we multiply by this minus 2x coefficient. Here this differentiated gives us a positive 4y raised to negative 5. So when we simplify, 3 times 2, we get 6. And then the answer is 6x cubed y minus 2x plus 4y raised to negative 5. In our third question, we have p equals 2y squared root x minus x raised to negative 3 plus 4y raised to negative 3x squared. To find the partial derivative of p with respect to x, differentiating the x's, first of all, as you see, I rewrote my root x as x to the half. So now differentiating the x's, This gives me half x to the negative half, and I multiply by the 2y squared coefficient. This will give us a positive 3x raised to negative 4, and on this side the x squared gets differentiated to give us 2x, and we multiply by this 4y raised to negative 3 coefficient. So simplifying, 2 times a half is 1, so this will give us y squared x to the negative half. Here the 3x to the negative 4 goes back, and on this side 2 times 4 is 8, leaving us with 8 y to the negative 3x. Same thing. So this becomes our answer. For the partial derivative of p with respect to y, we're differentiating the y's and the x's now act as constant. So when we differentiate this 2y squared, we get 4y, and we multiply by this x to the half coefficient. There is no y here, so when we differentiate it, it's acting as a constant to give us 0. Differentiating 4y raised to the negative 3 will give us a negative 12y raised to negative 4, and we multiply by the x squared coefficient. So simplifying makes our answer 4y root x minus 12y raised to negative 4 x squared. In this second example, notice that our function is different. We have two functions being multiplied, so in this case we have to use the product rule. So this first part, we're going to call it u, and the second part we're calling v. So now, to find the partial derivative with respect to x, this is the formula we will use. We have to find the partial derivative of the v function, multiply it by u, and the partial derivative of the u function and multiply it by v, then add the answers. So, to the side, I found my partial derivatives of u and v. So first I went to my u function, and remember once more we're finding the partial derivative with respect to x. So we are differentiating the x's and the y's are acting as constant. So here we will differentiate the x squared to get 2x and multiply by the y coefficient, giving us 2xy in our u function. When we go to the v function, this x squared will once again give us 2x, but this when differentiated, this y squared when differentiated will be a 0. So therefore the partial derivative of the v function with respect to x is simply 2x. So now we can plug everything into the formula for the product rule. So we'll put down the u function, x squared y plus y cubed, multiply by the partial derivative of v, which was 2x, plus the v function, x squared plus y squared, and that gets multiplied by the partial derivative of u, which was 2xy. In the line below, we simply expand. So 2x times x squared, 2x times x squared y will give us 2x cubed y. 2x times y cubed is simply 2xy cubed. Here, 2xy times x squared will be 2x cubed y, and 2xy times y squared is 2xy cubed. So when we group, we have a 2xy cubed, forgive me, we have a 2x cubed y plus a 2x cubed y will be 4x cubed y. This 2xy cubed plus another 2xy cubed is a 4xy cubed. Bear in mind, you can leave the answer at this line. For the second part, finding the partial derivative with respect to y, we're going to differentiate the y's and the x's act as constant. So we're still going to use our product rule formula, so we have to once more find the partial derivative of the u function with respect to y now and the v function with respect to y. So here, the y will get differentiated to give us 1, and we multiply by the x squared, so that's a x squared. And this y cubed gets differentiated to give us 3y squared. So therefore, the partial derivative with respect to y of the u function is x squared plus 3y squared. When we go to the v function, this will be a 0 because it's acting as a constant, and this y squared is simply 2y, as seen here. So now when we plug it into the formula, we'll first write the u function, which is x squared y plus y cubed, multiplied by the partial derivative with respect to v, which was 2y, plus the v function, which is x squared y squared, that gets multiplied by the partial derivative with respect to u, which is x squared plus 3y squared. So you can once more leave it at this line, but let's just go ahead and simplify. So 2y times x squared y will give us a 2x squared y squared. 2y times y cubed is a 2y to the fourth. X squared times x squared is x to the fourth, and x squared times y squared is x squared y squared. 3y squared times x squared is 3x squared y squared, and 3y squared times y squared is 3y to the fourth. Grouping, we have 2x squared y plus 1, x squared y is 3 x squared y, plus this 3x squared y will give us 6x squared y. So that's 2 plus 1 plus 3, 6x squared y. Here we have a 2y to the fourth with a 3y to the fourth. So 2 plus 3, 5y to the fourth, and this x to the 4 comes down. In this last question, once again we are finding partial derivative, but notice that our function f of xy equals 2x squared plus y cubed all raised to the power of 4. So it's raised to a power, which means that we're going to use the power rule. So for the partial derivative with respect to x, it's going to be power times coefficient is 4, write back the bracket, subtract 1 from the power to get 3. And now when we go inside the bracket to differentiate, we're going to be differentiating the x's and the y's act as constant. So this 2x squared differentiates, gives us a 4x, but when we differentiate this y cubed, it will be 0. So all we have now is 4 times 4x, which is 16x, and we write back the bracketed function. For the partial derivative with respect to y, we are, once more, power times coefficient is 4, write back the bracket, subtract 1 from the power to get 3, and now when we go inside the bracket, differentiating the y's and the x's act as constant, this will give us 0, and then the y cubed gives us 3y squared. So now multiplying 4 times 3y squared is a 12y squared, and we write back the bracketed function. In this last question, once again we are finding partial derivative, but notice that our function f of xy equals 2x squared plus y cubed all raised to the power of 4. So it's raised to a power, which means that we're going to use the power rule. So for the partial derivative with respect to x, it's going to be power times coefficient is 4, write back the bracket, subtract 1 from the power to get 3, and now when we go inside the bracket to differentiate, we're going to be differentiating the x's and the y's act as constant. So this 2x squared differentiates, gives us a 4x, but when we differentiate this y cubed, it will be 0. So all we have now is 4 times 4x, which is 16x, and we write back the bracketed function. For the partial derivative with respect to y, we are, once more, power times coefficient is 4, write back the bracket, subtract 1 from the power to get 3, and now when we go inside the bracket, differentiating the y's and the x's act as constant, this will give us 0, and then the y cubed gives us 3y squared. So now multiplying 4 times 3y squared is a 12y squared, and we write back the bracketed function.